Hi, in this video, we're going to talk about the inverse function, which specifically we're going to focus on the inverse function of exponential and log. Okay, now we're going to go over a few examples here. To find the rule of the inverse, what we do is we're going to swap x and y, and then we solve for y from there. All right. So if you look at my example here, they give me the original equation and they want me to find the inverse. So what I do, I have y equal ax plus 2. So I'm writing down the equation. Then I'm going to swap x and y. So y, I'm going to write x equal, and letter x, I'm going to write y. So ay plus 2. Okay. Then I'm going to solve for y. So to solve for y, there's a plus 2. So I move the 2 over by x minus 2 equal a to the power of y. Then I'm going to get rid of a. So to get rid of a, I'm going to log a on both sides of the equation. All right. So you will end up having log a of x minus 2 equal y. Okay. Therefore, the inverse function, which you can write f negative 1 of x, and then write that as log a of x minus 2, like that. Now, the second part of the questions is they ask you to find the domain and range of the inverse. So if you can remember the domain of the inverse, which would be the range of original, because you swap x and y, so the domain is the x value that will become the y value of the other function. So the domain becomes the range, and oppositely, the range will become the domain. Okay. So in these questions here, um, I'm going to find the domain and range of the original equation, and then I'm going to switch them around. So if I sketch f of x, you can see there's the asymptote here at y equal 2, right? And there's no reflection, so I know my shape will look like this. Okay, so the domain, so this is f of x here. So the domain of f of x, right, which is how much? Which is you go from negative infinity to positive infinity. So the domain of f of x is R, and the range of f of x will be you start the minimum to maximum. So you start from 2 and you go all the way to infinity. And you don't include number 2 because that's the asymptote. So you have 2 to infinity in the range of x. So once you've done that, then you can switch them around. So therefore the answer, so the domain of the original equal R. So this means the range of the inverse would be equal R. So pretty much just swap them around. And the range of original, this will become the domain of the inverse, and that's equal to infinity. All right. Now we're going to do another example. So this time we're going to deal with log. So the example is rewrite the equations, this equation with x as the subject. So they want you to solve for x. So let me just copy the equation again. Y equal to log a of x plus 3. Opposite of plus 3 minus 3 on both sides. Okay, so you would having y minus 3 equal to log a of x. Okay, then opposite of time by 2 is divide by 2. So you're going to get rid of the 2 here by dividing over. Now, we're going to get rid of log a, and opposite of log a is exponential that. So you do a to the power of that, and then a to the power of that. So a to the power of log a will go away. You will have x on the right hand side, and on this side you have a to the power of a minus y minus 3 over 2. And that's the answer. Here we go. We make x the subject. All right, now we're going to do one more example. This time we have a log equation and then want to find the inverse, which is we know that the answer is going to be back to exponential. So let's start writing the equation y equal to log a of x minus 1 plus 3. So to find the inverse, I swap x and y. So y become x equal to log a and x become y minus 1 plus 3. Then plus 3, I'm going to minus 3 on both sides. 3 and 3 go away. So I would have x minus 3 equal to log a of y minus 1. Then to get rid of the 2, I'm going to divide by 2 on both sides. So the 2 and the 2 go away. You would have x minus 3 over 2 equal log a of y minus 1. Let me just get rid of the 2. Then opposite of log a is exponential. So you do a to the power of that, a to the power of that. A and a will go away. So you have a to the power of the whole thing here equal y minus 1. Let me just write it. A to the power of x minus 3 over 2 equal y minus 1. And then to put the minus 1 to the other side, you're going to plus 1 here and get rid of the 1. Okay, so you will end up having the equation which is f inverse equal a to the power of x minus 3 over 2 plus 1. Now, to find the domain and range of the inverse, we're going to look at the original graph and we're going to find the domain range from there. So this one, if you look at this, this is a log graph, x minus 1, which means it's move 1 to the right. So the asymptote is x equal 1. And because there's no reflection, it looks like that. So you can check if the domain here is 1 to infinity, which is exactly matching with my graph. So I would have the domain. So I'm looking for the domain original, which is the range of the domain of the inverse, which is the range original. So if you look at this, the range original is going from negative infinity to positive infinity. So it's R. Okay. And the range of original is the domain of the range of inverse is the domain of original, which is going from the domain is going from 1 to infinity. So there you go, 1 to infinity. Okay, here's a last example how to rewrite. I have an equation here and they want me to solve for t. Let me make it bigger. So I'm going to write my equation t equal a e a t. So I want to solve for t. Okay. So this is time by a. So I'm going to divide it by a on both sides to get rid of the a. So I will have p over a equal e to the power of kt. Then to get rid of a, I'm going to log a and I do log A on both sides. Log A and A will go away. So you're left with log A of P over A equal KT. Okay. Then to get rid of K, because I want to make T the subject, this is time by K, so I divide it by K. So to divide it by K, you can do divided by K like that, but the better way to make it look nicer, you can write just 1 over K in the front. So there you go. So T will be equal that answer.